Good morning, everybody. I'm going to talk about moving software out of university into the commercial world. And this morning I'm going to talk a little bit about what makes good value in software, either for you trying to sell it or for an investor looking at funding your spin out. This afternoon I'm going to come back with lots of examples of how universities have succeeded in doing this. So why am I talking to you about this? Well, I studied at Cambridge for 8 years as a scientist in electronic engineering, semiconductor materials, and then I moved into the software industry, where I worked for 20 years in small companies. My first company had 3 people when I joined. Later on, I joined a company with 6 or 7 people, and we grew that to 100 people. And when you're a director of a company with 100 people, it can be quite scary because, you have to sell several million euros of software every year just to pay your employees. And to do that, you have to have high-quality software with value that a customer wants to buy. I then moved into university. I worked at Lancaster University for 12 years doing technology transfer, helping the academics move their ideas from all branches of science and from software into products and out to the outside world, licensing to industry. I'm now retired. I do teaching for Praxis and for ASTP, which are the European organizations that are the professional bodies for technology transfer. So let's start by looking at software that's going to go to consumers or is going to go into apps. This is a very difficult market because customers expect all this to be free, which means it's hard to make money. If you play games, often the games are free and the companies make money by adding extra features. So if you're going to this market, you have to think very carefully, what are people going to pay extra for? Where is the value? Why are they going to pay you money? As an example of an app that's come from a university, this is called Mersey Burns, from Manchester University in the UK. The PhD student was before in the army. He was a doctor, and he saw many people with burns. When a patient arrives at the emergency room with burns, you have to give them fluids, but giving the correct amount of the correct fluids requires skill and training, and this application helps people in the emergency room to do that. Because he was a doctor writing software for doctors, he decided this should be free. One point I'll come back to is that if your software is in the medical area, it may be a medical device. And before you can sell it, you may have to take it through the long approval process for medical devices. That was the case with this piece of software. So it is approved as a medical device, it has a CE mark, and it's regulated by the regulator in the UK. If we're looking for value, as we've learned this morning, software is easy to re-engineer. This is good if you're writing software, bad if you're trying to make money from selling software. The source code is protected by copyright, but copyright's really quite a weak protection. The idea itself is not protected unless you're able to go for a patent. Most software doesn't use patents because the lifetime of software is maybe 3, 4, 5 years, and it may take you that long to get a patent. So a patent is really useful if you have some fundamental new technology or some fundamental new way of interacting with hardware. So the question then arises, exactly what can you copy, what can you not copy? So who's heard of EasyJet? Everyone, I hope. So that's a UK airline with orange aeroplanes. And back in the early 2000s when they set up, you could only buy a ticket for EasyJet through the internet, not through a travel agency. This was one of their unique selling points to keep their costs down low. And they used a company called Navitaire to write their web shop. But Navitaire owned the software, and Navitaire kept charging EasyJet money. As the number of customers went up, they had to pay more money to Navitaire. So EasyJet decided to rewrite the software, and they got a third company in to write the software. And when they swapped over to the new software, no money was going to Navitaire, and Navitaire sued EasyJet, and this case went to court. And the findings are very important for UK law, but also for European law. And so the results they found were that copying a look and feel, that's okay. Copying the commands and the business logic, the way the website flows through, that's okay. Copying the graphical user interface, that's a bit of a grey area. You can copy some things, but not others where there's some artistic nature to them. So having a button that says OK or click to approve a license, that's okay because that's necessary functionality. Copying artwork, photographs, that's not okay. So these are really the ground rules for software. The source code itself is strongly protected by copyright. So if you're going to copy some software, you must not see the source code. And if you're going to ask somebody to reinvent your software equally, you must not let them see the old source code. So this means software is quite easy to copy. Products are quite easy to copy. So what we need are some barriers to re-engineering. And what we really want to do is make it hard for the new software engineer. So the software engineer will look at your application and say, that's a table, they get some data from here, I can see how the workflow is done, I can rebuild that. So what you need is something where the software engineer says, yes, 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 but how do they do that? And that's what we're looking for, an algorithm, how do they do that? So I have a couple of examples. There's a company in the UK called Opta, and they analyze sports events, particularly they analyze football. So they record where every player is every second of the match, who's kicking the ball, where they're kicking the ball, who they pass it to at every moment. This is obviously very valuable to football clubs, but also to journalists and to coaching organizations and to people like UFA. They started about 20 years ago with people watching matches and coding this all by hand into databases. Now they have software that helps the people, a little bit like machine translation helps translators. But they now have a huge database. They can go back 20 years. So a football club can say, how many corners did we get when we played Manchester United each year in the past? Which clubs do we seem to get red cards against? And so on. Anybody could copy that, but because Opta has 20 years of data and they have the expertise, it's very hard. So they have the market to themselves. One that I worked on when I was a software engineer was a trading system for international banks, for currency traders. Most of the screen is telling them what the markets are doing, but there's a little white bit in the top screen where they trade. And they trade by having a conversation. It's a little bit like a text message conversation. They need to do it really fast. And the box at the bottom left is an example of one of these conversations. And what we did was build a set of rules that turned that very cryptic text into what they call the ticket, the deal information. And we did that by spending many months sitting with dealers in trading rooms, building up a huge database of these conversations and tickets. So somebody else could do that, but they'd have to start again. They'd need many months and a lot of time to do that. So if you want to put value into your software, something has to be unique. You need a unique database, you need some sector knowledge, and how do they do that algorithm? If you're a commercial company, you could be first or best or biggest, but that's not really what universities are able to do. So how do we decide the price and the value of something? The best way is to go and look at systems that are out there in the market. So the most expensive one I could find was the Bloomberg terminal. If you trade bonds in the international markets, you need one of these, and it will cost you or cost your bank about $20,000 a year to put this on your desk. Banks are very good customers. They're very demanding customers. Your software has to be very good, very accurate, very fast, no bugs. If you can achieve that, they pay a lot of money for their software. Going down scale, there are bits of software used by other professionals, computer-aided design systems, mathematical systems like MATLAB, where you're paying perhaps up to $1,000 a year for those applications. There are enterprise resource planning applications like SAP. If you're a small business and you want to run your finance and your stock control and your sales on SAP, it will probably cost you $500 per person. And more recently, Microsoft has said it wants to stop selling you Microsoft Office when you buy a new PC, but to put it online, software as a service, and to charge you for that. That, I think, is very dangerous. If they're going to ask me to pay $175 a year, I'm going to use OpenOffice. It's free. So sometimes that business model is dangerous. So if you're writing software, you need to look at the market and say, what do people pay for similar applications? Is mine as good as that? Can I justify that sort of price? You then have to think about, if that's the price in the market, how much will it cost me to build my software? Am I going to get enough sales to justify that price? So that's the sort of thing you have to put in your business plan to prove that it's going to work. So an example to think about, the sort of thing that happens often in universities. An example of a student who goes to work with a company during a PhD and applies their expertise to writing some software. That software could be very valuable to the company. So in this case, if the software is owned by the university, the company wants to buy the software, what's a fair price and what model should we use? Should it be an annual fee? Should we sell the software once? So who thinks the most important figure is the 200,000 euros of savings? Nobody. And who thinks the most important figure is the 8 weeks of students' time? Oh, well, you're not communicating very much. But they're both very important things. So we could say, well, 200,000 is too much because the company won't buy the software, it costs that much. Maybe we could charge 50,000 euros a year. That's reasonable. We make some money. They still make a big saving. But if we do that, the company will say, it took a student 8 weeks. It could take somebody in our IT department 8 weeks. That won't cost us 50,000 euros, so we'll do that. So there's always a balance between the cost of developing the software and the benefit that's achieved. So here I think we might ask the company maybe 10, 15,000 euros a year. It's a small amount. They will look at that and say, okay, it saves us money, but it's not high enough that they're going to want to build it themselves. So there's always the balance. Look at what it costs you, but look at what the customer might do. A little bit like a chess game. What will their move be if I move here? So if you're looking for positive value, we want some barriers. As we've heard earlier, patents can be positive. One advantage a university has is that we're innovative. We're doing new things. If you can be first into a new market, you can make a lot of money there. So that's a good thing to do. So now I'm going to start looking at some of the more negative things you need to be aware of and maybe avoid if you're writing software. So is there a market for it? Are there other patents? Do we have users' data we need to be aware of? Is the software good enough? And is it a medical device? So a nice example here, we have an Englishman trying to make a cup of tea with a Wi-Fi kettle. This sounds quite good. It's Internet of everything. You can switch on your kettle from your phone. But actually, what if there's no water in the kettle and the kettle's in the kitchen? You still have to walk from your desk to make the cup of tea. So it's kind of a halfway solution. It doesn't do the job. What we really want is a Wi-Fi tea-making drone that I can command from my desk that will fill itself with water, make me a nice cup of tea, fly it to my desk, and bring me a chocolate biscuit. So that's what people want. And often in industry, new products go through a complicated process. You have requirements from customers or the marketing team that go through various managers, go through the design team. They'll prototype and build it, and maybe you go around the loop several times in an agile way. In universities, we just tend to do this. We think of a good idea, we prototype it, and we build it. And it's not market tested. So very often, university products don't succeed in the market. We heard about software patents before, so I won't say much about those. But if you're starting a spin-out company and you want to attract venture investors, having patents is good. So in my experience, I've probably worked on about 20 software patents. They're not too hard to do. As long as you have the right technical features, they will go through the system. Where they tend to fail is on the inventive step, because the patent examiner can always find lots of other pieces of software that do similar things. So that's the big difficulty in practice. GDPR, I'm sure you know these letters. You need to look inside your application. Do you have user data, either in your database or in cookies on the user's machine? If so, you have to make sure that users have the rights to find out about that, to ask you to remove them, and so on. And you need to appoint a data protection officer. That's a named person. So in your business plan, you need to make sure that you have that. Is your software good enough for the application you have in mind? So here are some things your software might do. And as we go down the page, the software gets more and more critical. At the top, we're just processing some results. At the bottom, someone's life may depend on your software. So is your software good enough? And there is a formal scale for this called CMMI, which looks at the capability of the development process. So if you're in a university, I'm sure many of you write academic papers, which you send to journals. And you probably ask your colleagues to read them first. If you write software, you probably don't ask your colleagues to read it first. But if you're in a commercial company, all software is looked at by 2 or 3 people before it goes anywhere. So if you don't review your software, you're probably down at level 1 in this system. If you're in IBM or NASA or a medical device company, you're probably at level 5. You have quality systems in place to make sure that your software does exactly what it's supposed to do, is robust, and if the power goes off or something like that, your software fails in a nice way. I should say, I think you're going to get copies of all my slides later on, and there are many links in the slides that you can use to follow up these things. We have European medical device directives. You don't have to read all that, but the important part is that it includes software, whether the software is on its own or used in other things. And if you intend it to be used on humans for diagnosis, prevention, monitoring, and any of these other things, then your software is a medical device. That can be good because it can mean it has very high value. It could be very useful to doctors. The downside is you have to get your software approved. And as part of that, you have to provide lots of documentation on how you've designed it, how you've tested it, and that it meets all the requirements. So, as a summary of the value of your software, you need to look at what's inside. We've heard of free and open source software. Is there any user data there? Is it any good? Is it fit for purpose? Have you got any of these great barriers in that you need? Is it a medical device? And if you're happy about all those, you can go forward. You can either start to sell your software or form a spin-out company to develop it further. And these are questions that any venture capitalist will ask of you and you need to cover in your business plan. So now I'm just going to talk briefly about licensing of university software. And there are really 3 kinds of license that we see many, many times. We've talked a bit about open source licensing, and that's great if you're licensing out code. We've heard from Matthew that there's a spectrum from copyleft, which is the most restrictive, down to permissive, which lets you do almost everything that you want. One thing to be aware of is to look at your funding. If your research was funded by a charity, some charities have conditions in their contracts that say things like, our funding must not be used for military purposes. If your funder says something like that, you can't release your software as free and open source, because free and open source means anybody can use it for anything, including the military. So it's always worth looking back at your funding. If you're going to sell to consumers, you need an end-user license agreement. I'm sure you're familiar with those. They're the kind of license that when you are doing something online, it says click here to say that you've agreed the licensing conditions. Sometimes those websites don't force you to read the licensing conditions. Some lawyers think that's a little bit dangerous. It's much better to make users scroll all the way down a page, as in my example, so that at least the conditions go in front of their eyes, and then at the bottom you have the button that says next. And then the final kind of license that we have is the license where universities license software to a company to use in their own products. And these kind of licenses are the sort of licenses we use when we're licensing patents or know-how or materials to companies. I should say, with all these kind of licenses, always talk to your university lawyers, because they're the people who know which license is best, and they'll make sure that all the terms and conditions are correct. So that's the end of the presentation. We have some time for questions.
Yeah, sure. So if anyone wants to ask something?
I have two questions. So in case of end-user licenses, how do you then deal with the support and updates and so on? Because, of course, researchers are not there. They're not a company. They're not there 24/7. How do you deal with that, or you have any experience?
Yes, so as a tech transfer office, when we're trying to commercialize software, we're very aware that the researchers have usually given us the software as a finished piece of software, and they want to move on and do other things. And that can restrict some of the value you can get from software. And if that's the case, I would normally try and either put it into a spin-out company or license it to a third-party company so that they can provide the updates and they can provide the service. Academics do not want a phone call in the middle of the night from Australia saying, your software has just died, please fix the bug. And we mustn't expect that. And part of the job of the tech transfer office in software, as in other areas, is to take that work away from the academics, so the academics carry on doing the research, carry on doing the great new things, and we look after all the difficulties of commercialization.
And also, do you have any maybe bad examples of cases like, you know, when the researcher comes and actually the software has maybe great market potential, but it was not looked at it as such, and it was not thought through in advance, certain things like maybe protection, maybe the algorithm is already published or something like that, and how did you then deal with those situations?
Yes, those are all the difficulties that we have in the tech transfer office. One simple example I had was, it was before the days of apps, but we had a postdoc researcher who made a utility that he put onto the web, and you could download this for free, and he had about 20,000 downloads. And he thought, this is good, I'm going to charge 99 cents, because it was on an American site. When he charged 99 cents, he had no more downloads. Nobody wanted the software when they had to pay for it. And that's a difficult decision when you see a good piece of software, trying to work out what the market is. Generally, I think, as I said before, if it's a consumer market, it's very difficult to monetize. Much better if it's a researcher who's been working closely with industry, knows what industry wants, but is able to write some software that solves a problem for industry. If you have that, that's great. And in between, there's a whole grey area where you do your best as a tech transfer officer. Sometimes it works, sometimes it doesn't.